So we are going to start with this particular structure you can see here. For convenience, I'm just going to indicate the structure yet again so that I get to number correctly. So the structure is like this. Have bromine, then we have this, we have this. So if you've watched the previous video where I explained the different ways to represent organic compounds, we have the bond line, condensed formula method, molecular formula method. Okay, you can see that in this video description. But first, let's head to naming this compound. So the first thing, you have to identify the longest chain. And if you look closely, there's a carbon here, there's a carbon here. This is 2, this is 3, this is 4, and this is 5, right? So we know that this is a pentane. Since we've identified that, we try to give these substituents. This is a substituent, this is a substituent, this is a substituent. We have a bromo, an iodo, and a chloro. So we are going to give them the lowest numbers possible. So if this is 1, this is 2, and this is 3, and here is 4, and here is 5, which gave us pentane, right? Which is 5 carbons, right? So now we have to check which route are we going to follow. Are we going from right to left? That's 1, 2, 3, or are we going from left to right? In order to know which of the substituents should have the smallest number. So if you are going from right to left, that's 1, 2, 3, 4. That means bromo is on the 3rd, iodo is on the 4th, right? Then chloro is on the 5th, right? So but then if we are going the other way, if we are going to number this the other way around, that's from left to right, it just means that we are going to have 1 here, 2 here, 3 here, which is still 3, then we have 4 here, and then we have 5 here. And in that case, our bromo, as you can see, will still retain the 3rd position, right? And the iodo would have the 2nd position, and the chloro would have the 1 that's the 1st position. And as you can see, looking at it, we can actually judge for the fact that we need to give the lowest number possible, and the lowest number possible is from left to right. 3 plus 2, 5, 6. Can you see? Total of 6 moves. Here we have 9, 10, 11, 12. So definitely we can't go from right to left. Instead, we'll go with this because it's giving the substituents the lowest numbers possible. So this is how we are going to name it. So we are going to go from left to right. So since we are going to go from the left to right, meaning that we won't be going from right to left. That is to say, for us to name this particular structure you see here, then we are going to name them. As you can see, we have different substituents. We're going to name them in alphabetical order. Bromine comes before chlorine. We have letter B before letter C, and letter C comes before letter I. So that is the trend we are going to follow. All right, so we're going to start with the bromine. Bromine is on the 3rd carbon, as you can see here, right? So it's going to be 3 bromo, all right? Then what's the next one? Chlorine, right? So we're going to have 1 chloro. Then we have iodine, so it's going to be on the 2nd, right? So it's going to be 2 iodo. Then we now call at the parent name, which is the pentane. Then we write pentane. So that is the name to this compound. Is that easy, right? So let's try some other one. Let me also draw it for convenience. Just like this looks like letter M. Then we have a straight. Then we have this. We have that. Then we have this one. Then we have that one. All right. So you see, and we are supposed to name the structure, right? Now, usually, what we first have to do is to find the longest chain, right? So if I go from 1, 2, 3, 4, 5, I get a 5, right? So let's go the other way around. Let's try 1, 2, 3, 4, 5, 6. This particular one makes the 7th. So you see the longest chain here in this case is 7, meaning that this is a heptane. Can you see that? Now we will now have to consider the substituent, that is to say the carbons we did not count. Since we know that this is a heptane, so you remember we didn't count this area, and this area is 2 carbon, that is ethyl. That's an ethyl. All right, then if you look closely again, we didn't count this. This is methyl, just 1 carbon there, so it's methyl. Then which other one did we? Okay, that's just it. So we just have basically 2 substituents, an ethyl and a methyl. And just like we've said in the previous one, you have to name alphabetically. Letter E comes before letter M. So that means we're going to start with the ethyl. And we have to note the positions. Let's give the substituent the lowest numbers possible. Now, if this is 1, and this is 2, and this is 3, and this is 4, here is 5, here is 6, and here is 7, right? So if we are going from left or right to left this way, our ethyl will be on carbon 3, while our methyl will be on carbon 4, as you can see here, right? So, but if we are going from left to right, what is it going to be? So that means 7 is going to be our 1, this is going to be 2, here is going to be 3, here is going to be 4, that's say our methyl will be on the 4th, right? Here is going to be the 5th, right? So that's to tell you that our methyl is going to be on the 4th, and our ethyl is going to be on the 5th. If you total this is 9, this is 7. So we can't go from left to right. Instead, we go from right to left. So we're going to go 1, 2, 3. All right. So it's going to be what's the first letter? Ethyl. So we're going to have 3 ethyl, right? Then 4 methyl. Then we have the parent name, which is heptane. Can you see that? So that is the name to this structure, and that is how you name it. Okay, so I believe this should be clear enough going by the previous example, and we'll look into some other classification. So we are going to look at naming of alkene and alkyne. That's some other functional group classification of hydrocarbons. Okay, I'm going to break it open for more clarity. What that means is that we have a carbon to carbon triple bond, then we have a carbon here, which is CH2 basically. All right, then we have another one, all right, that is another CH2. Then we have another one attached to chlorine. Let me just try to make it more clear with the writing. So we have CH2. Let me put the H here and put another H here. Then before you have the chlorine. All right. Now you see. So basically, this is what we have, and then I missed to put H here because there's an H here. All right. Now we have to number. Remember, we have to give the substituent the lowest number possible, and then the shortest number possible for the functional group. And if you look closely, the functional group here is an alkyne. This is an alkyne, right? So in that case, if we're going to number, if this is 1, all right, and this is 2, and this is 3, and here will be 4, right? So that means I'm giving the alkyne, which is the functional group, the lowest number possible, which is 1. So it's more clear, it's more even evidence that that is the lowest number ever, 1. So because if we start numbering from here, 1, 2, 3, we'll be giving it probably the third or fourth, which is not, it's not possible, right? So in this case, so we are going to go from left to right, all right? Meaning that we are going to exclude moving from right to left. So the parent name, what is it? How many carbons? We have 1, we have this one, we have 2, we have 3, and we have 4. So, and that is to say the parent name, bear in mind it is an alkyne, so we know that this is 1-butyne, or let's just say butyne in the first place. Then if we want to name it, we will look at the substituent. The substituent is a chlorine, which is a chloro. So we're going to have 4-chloro, right? Then we have 4-chloro. What is the parent name? And it's a 1, right? Because the alkyne, the triple bond is on the first carbon. So we're going to have both 1-ine. Or you can say 4-chloro, 1-butyne. That's still the same thing, all right? So this is how you name it. So basically that's the name to this structure, which you can see there. Now let's take another one. So if you look at this structure, I believe everything is satisfied. You get to see we have an alkene and we have an alkyne, bonds here. So for you to name this, when you encounter a structure having this, you have to name them still alphabetically. The alkene is ENE, the alkyne is YNA. So ENE, letter E comes before letter Y. So we're going to name number the positions based on which comes first, alkene. So we have to number following the alkene side. So we have to start numbering from here. It's going to be 1, 2, here's 3, here's 4, and here's 5. So that means, what is our parent name? If you look closely, our parent name, that's 5. So it's going to be bent. Remember, we are naming from the alkene side, so it's going to be bent. 1, because the double bond is on the first carbon, so we're going to have bent 1 in, all right? Then just join it together. The triple bond, you can see here, is on the fourth carbon, so it's going to be 4YNE. So this is the name, bent 1 in for wine. It's funny, right? So that's the name to this structure. We are going to look at even much more in-depth naming of structures. What I mean is that we're going to look at compounds containing the carboxylic functional group, and at the same time containing the OH group, and at the same time containing double bond. So there's something that we call preference when we are naming organic compounds, naming the structures. So whenever you see a carboxylic group occurring and this functional group alcohol occurring at the same time in a structure, all right, you will tend to give the parent name to that compound to be that of a carboxylic. So we take carboxylic acids as preference once they occur as a functional group in the structures. So if, for example, we have this is the aldehyde, which you can write this way. If you have this occurring in a compound and at the same time you have an OH occurring in a compound, we tend to give the aldehyde the parent name. That is what I want you to know. And in that regard, I've provided the priority order. The priority order which would guide you once you get to see them occurring in an organic structure to tell you which of the functional group will bear the parent name. So we basically have the carboxylic acid as first, Then we have the esters. Second, then we have the amide, if you see them occurring. So next we have the aldehyde. Okay. Then we have the ketones. All right. Then we have the alcohols. I mentioned alcohols. Then you can even have the amines can come next. Then you can have the triple, double bond, single bonds. Okay. So whenever either of these are occurring in a compound, just know that the one at the top will bear the parent name. If, for example, we have the ketone and the amine occurring at the same time in a compound, know that the one to bear the parent name is the ketone. So the ketone has more preference than the amine. That's what I basically want you to understand. So with this knowledge, let's get to name a particular compound. So you can observe this particular structure we have here. If you look closely, we have the carboxylic functional group. That's the COOH. Okay. Then we have the amino, which is NH2. Then that is all. We have a phenyl group. Phenyl is this way, just benzene ring. So this is the phenyl. Looking at the priority order, we know that the parent name is going to be the carboxylic acid functional group. So what we are going to do, let me wipe here off. Just the same way we've been naming, we have to look for the parent name, the longest chain, right? So we already know the parent functional group. So we are going to look for the longest chain, and we are going to count the carbon atoms. Okay, so you can see here, and we usually tend to give the parent name the shortest number possible. So we know that the parent name is the carboxylic functional group, which you can see here. It's obvious that we're going to start counting from here. 1, 2, this is second carbon, third carbon, fourth carbon. So on the fourth carbon, we have the phenyl group, which you can see here, right? On the second carbon, we have the NH2 group, which is the amino group. And we know that the parent name is going to be the functional group containing the carboxylic acid functional group, which is this, right? So what we're going to do is, what is the number of carbons we've counted? 4, right? And we know this could just be from butane. So instead of saying butane, we know that this is carboxylic functional group, and it's going to end with OIC. You know, they are the alkanoic. So instead of saying butane, so we're going to say this is what? Butanoic acid. So this is butanoic. We know that this is a butanoic acid, right? Going by the parent name, butane, 4 carbon, functional group OIC, the carboxylic acid functional group. Then if you look closely on the second carbon, which you can see here, on the second carbon, there is an NH2. So it's going to be 2 amino. So we are bringing it out. Then on the fourth carbon, which you can see here, we have the phenyl. So we have 4 phenyl. So if you look closely now, we've broken down every component of the structure. So we are going to arrange them alphabetical order for the substituents. So we have the 2 amino. A comes before P. So A comes before P. So we start naming by saying 2 amino, then 4 phenyl butanoic acid. So that's the name to this compound. Now you can see how the priority order tends to, have an effect in the naming of organic structures. Let's take one more example to illustrate this priority order. Now this is another structure. If you look closely, we have the OH functional group, then we have the ketone functional group, right? Because judging by the fact that we have an alkyl here and an alkyl here, so that's a ketone functional group. So in that regard, since we've identified the two functional group, the ketone and the hydroxy functional group, from the priority order list, the parent name has to bear the ketone functional group. And for ketones, the suffix ends in ONE. All right. So if we have a propane or 3 carbon atom structured, organic compound, so it's going to be propanone. From propane, we have propanone. All right. So that's basically it. If you look at the structure, we have to give the list number to the functional group. To the parent name, that's to the functional group. So if we start naming from the right, here will be 1, here will be 2, and here will be 3, right? That is to say our parent name is on the third carbon, right? So, but if we name from the left, if here is 1, here is 2, here is 3, that means it's going to be on the fourth. Here will be 4, which we don't want. So we have to give the list number to the carbon bearing the functional group. So we are definitely going from right to left. Okay. So, and then what is the longest chain? So if we proceed, this is the third, here is going to be fourth, fifth, and sixth. So this is from hexane. Hexane has 6 carbon, but in this case, this is going to be a hexanone. Can you see? So you see, it's going to be a hexanone. And what kind of hexanone? The functional group is on the third carbon, so it's going to be a 3 hexanone. All right. So then we look at the substituent. That's the other functional group. It's going to serve as substituent this time around, and if you can see, it's on the 4th carbon, right? So to name this compound, we are going to say 4-hydroxy, right? Then this is 3-hexanone, so we're going to have 3-hexanone. Can you see that?